When you're looking at the ceiling, what do you notice about these panels? They're parallel, right? Yeah. If you look at K, right here, and you look at this strip, and I say, hey, this strip is parallel to this, given. So let's call this strip 1, this is strip 2. Strip 1 is parallel to strip 2. Then I tell you that strip 2 is parallel to strip 3. What can you conclude now?
Strip 1 is parallel to strip 3.
1 and 3. Kind of like a transitive, isn't it? 1 is to 2, 2 is to 3, take out the 2, 1 and 3. But it's not transitive because transitive is just equal, equal, equal. Okay? So, that's what this guy's saying. If two lines are parallel to the same line, then they are what to each other?
Parallel.
Are lines parallel or congruent ever? No. Alright, that parallel should be up there on that line. I don't know why it can't be up there. So, look at my example. A is parallel to B. B is parallel to C. So, therefore?
A is parallel to C.
Alright. Understandable?
Yes.
Okay. Next example. If this crease is 90 and this crease is 90, that means that these strips are parallel. So, in a plane, if two lines are, well, I use the word perpendicular on the theorem, but doesn't perpendicular mean two things that cross at 90? Okay, so if two lines are perpendicular to the same line, then they are parallel to each other. So in this picture, I have given this. What is that?
Perpendicular.
So if you forgot that that upside down capital T means perpendicular, write that in there. This symbol means perpendicular. Perpendicular means it makes a 90 when they cross. Okay? So I'm saying that M is perpendicular with T. So I put a box in there. And then I say that N is perpendicular with T. So I put a box there. If I have that, what's true? M is parallel to N. Why is that? Well, here's the theorem, or the proof for it. So we're going to now explain why this is true, why it works. So, given R is perpendicular to T, S is perpendicular to T. You could put that as one step or two, it doesn't matter. Now, if I tell you something's perpendicular, what does that mean to you? Let's not say 90, let's say that it makes a right angle. So this guy is going to give me a right angle, and this guy is going to give me a right angle. Which one is a right angle because of R and T being perpendicular? Up on this picture, which angle is going to be a right angle because of R being perpendicular to T? 1. Agree? R to T makes angle 190. T to S makes what 90, or right angle? Angle 2. Why can't I justify this? Yeah, why can I say this? What's my reason? We're not going to use this theorem because we're proving this theorem. It's a definition of perpendicular. Yeah, it's not up there yet because we just started this unit. Definition of perpendicular. Because I literally asked you, what does that mean, perpendicular? And you replied, it means a right angle. So we defined what this meant, and then we defined what that meant. Okay? Somebody another hour said, no, we define a right angle. No, what does it mean if I define what a right angle is? It means 90. Okay? So now, think about that right there. You grab that. Alright, so I have angle 1 is a right angle 2 is a right angle. What can you declare, do you think? They are congruent. If angle 1 is a right angle and angle 2 is a right angle, then obviously angle 1 will be congruent to angle 2, but I can't write obviously for a reason. What do I write? If two angles are right angles, then they are congruent. Didn't you guys have that on your quiz last time? A paragraph proof? Right? It was a picture given. Those two angles are right angles. Prove that they are congruent. And you said if two angles are right angles, they are congruent. Here we go, using it in a 2-column proof. Now, if 1 and 2 are congruent, and we look at that picture, look at where they are. Corresponding. So if 1 and 2 are congruent, do you agree that R would be parallel to S? What do I write? Angles are congruent, then parallel lines. Lines, not lies. Lines. Now, please understand, this became my if. That became my then. Always. Okay? If I am saying, if I end my proof with a prove that things are parallel, then I should be saying then parallel as my very last conclusion. Okay? Okay. Questions on that proof? Now again, this is the explanation of why this theorem exists. So we don't have to do this again. We can just say this theorem. Okay? All right. All right, you're in a workshop and you have these 4 pieces of wood laying around. I want to know, can you make a picture frame with it? So, I literally have 4 pieces of paper and I want to know, can you make a picture frame with that? So somebody come up and make a picture frame for me. And we'll sit here and do nothing until someone comes up. All right, Skylar. I'm going to tape you. Awkward.
Hey, which way do I do it?
I don't know. Make a picture frame. You guys can help her.
I don't know. What the heck?
Goes on the sides. Goes on one side. And the other 2 is on top.
The big ones are the
Direct
sides.
her.
There you go.
Like,
Yep, like that.
And then the other side.
Yeah. National Geographic.
Now, I need to prove, because what does the directions say? Does it say just make a picture frame?
No.
It said construct a picture frame where opposite sides parallel. Well, they look it, good enough, right? No. If anything, you've learned that you can't say that kind of stuff in here, right? We got to justify it. So, how do we prove parallel? 4 ways. If corresponding angles are congruent, then parallel lines. If alternate interior angles are congruent, then parallel lines. If blah, 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 right? The other 2. What do I want to use there to prove parallel lines? Where do you see corresponding? Vertical angles never prove parallel. Vertical angles never prove parallel. Never. Where do you guys see corresponding at? It's on your paper.
Yeah.
What? There's my my picture frame right here, right? Some of you guys are saying like alternate interior angles. Is this even existing on your picture? What about same side interior? Supplementary. So we need same side interior angle supplementary. Do I have that? How? What? 60 and 30 make 90, correct? Yay. 60 plus 30 makes 90. So look, this is 90. Is this 90? So this is 90, this is 90. So therefore, are those supplementary? That makes what parallel then? Top, bottom, left, right. Just saying this is 90 and this is 90. Those now are parallel. That one and that one. I need both pairs parallel. Is this 90? Is this 90? Do I even care that those are both 90? No, because those are already parallel. We got them parallel up here. That one's 90, that one's 90. So now, same side interior angles are supplementary this way. So now these are parallel. So we use the if same side interior angles are supplementary, then parallel lines twice to explain why those are parallel and those. You with me? Okay, so write down whatever you need to relearn and relive this moment we just had. Alright, so I just said use if same side interior angles are supplementary, then parallel lines twice. Okay? And when we rearranged that, you should have saw 90 in each corner, which means that the top and bottom would have been parallel, the left and right would have been parallel. Okay.